Good morning, all of you. Let's begin our session. We have been discussing about different concepts in Docker, and today's concept is Docker volumes. And just for your information, I have uploaded the notes till today's class. What are volumes? Docker containers are ephemeral. That means they are temporary. Once they are created, and if we delete them, then the data that is processed by the particular container or the data that is being generated by that container will be lost. But we don't want that to happen, right? So how to preserve the data, how to retain the data? For that, we have the concept of Docker volumes. What I'm telling here is we have Docker host. Then after that, what we are doing inside Docker host, we are creating some container. Let's say this is Ubuntu container. Let's say we have created some files. Let's say we have created file 1, file 2, file 3. Okay. If this container is deleted for some reason, then what will happen? These files also will get deleted, but we don't want that to happen. So instead, what we can do, we can create a volume in Docker host. Okay, that means we will sync this volume to this container and particular path of the container, particular directory. We will see that. Then once these files are created here, then these files will be syncing here in this volume as well, right? So even if this container is deleted, our files will be there in our Docker host machine. This is what we are trying to see. Now, how to demonstrate, how to confirm whether the data that is being created by that particular container is preserved in the Docker host or not. For that, let's see, we have a directory cd var lib docker. To go here, in this we have another directory called volumes. To come here, let's see, we don't have any volumes here. That means you don't understand that. Now let's create a container, docker run -- name. Let's name it as my Ubuntu container. Let's interact with it. The image is Ubuntu. This image is unable to find in the local, so it is trying to connect to hub.docker.com. It is being pulled from that server. Now the prompt has been changed to the container. Now let's do one thing. Now let's create a file, touch file 1, touch file 2, touch file 3. We have created these files. Now let's exit from this container, right? Now if you see, if we list out the volumes in this, so those files, a volume for those, that container is not created. You will understand after we create some volume, right? So that container is exited and we lost that file. Okay, and exited means it is in stop state. Once we run it, that is fine. But now let's remove that container altogether. Docker ps file a docker rm Ubuntu. Let's remove that image. So that files were gone. Now, how to preserve those files? That is what our concept is. For that, we have the concept of volumes. There are 3 kinds of volumes. One is anonymous volume. In anonymous volume, create a container with anonymous volume which is mounted as data 01 directory on container. In this case, we mention container directory name. On host system, it maps to a random hash directory under var lib docker directory. That means, let me tell you this. Docker run, interact with it. I want to name that container as web UAT. Now, this is the image name and this is the terminal. If you don't mention it, by default, it will be bash terminal. Now, here the new option came. What it is? It is hyphen small way. And we have another thing here. What is the argument for this option? Slash data 01. That means a container with this web UAT name will be created, and in that a directory will be present. This directory can be present already, or if it is not there, this directory will be created in this container, and for that a volume will be created, and we are not specifying the name of the volume. So if you are not specifying the name of the volume, a volume with anonymous name with some random hash name will be created in this particular location. Okay, that we will see. Now let's execute this command. If we execute this command, let's open one more terminal so that you will see that properly. Copy the Docker host IP address, specify username. Ubuntu is the username in our case. Browse for the private key. In my case, it is located in the download section. Now clear this, log in as the root user. Then now let's execute this command here. So before that, what I want to do, let's copy this. Now what I want to do is volumes. What it will live stream the particular this directory is there, right? It will list out the files and folders and it will refresh every 1 second. This is one of the Linux command. So if you don't understand, you can work with it. So as of now, what it is doing, for every seconds, this ls command will be refreshed in which directory? In this directory. Now, as of now, only these two files are there. Now let's do one thing. So let me get this back. Now this is one terminal, this is another terminal. Now let's do one thing. What I have done. Now let me execute this command. This command I will explain once again. We are creating a container from this image and we are naming that container as web UAT01 and I want to interact with this container. Additionally, we are creating a volume for this container. That means whatever the files that are there in the data01 directory will be mounted to this particular volume, and we are not specifying the volume name here. So some volume with some random hashtag will be generated and in this particular volumes directory. So now let me draw image for this so that you will understand that properly. It's very important. This is a container. Inside the container, we will be having directories, right? So in our case, let's say directory data 01 in root. Then what we are trying to do, we are creating a volume we are not naming this volume. Once we understand the naming the volume, then we will understand this volume. Then what we are doing, we will mount this directory to this volume. So whatever the files that will be created in this directory will be coming here as well. And if there are another directories in the same, definitely other directories will be there in this container, but those files won't be coming here. But the files which we create in this data 01 directory only will come here and they will be saved. Now let's do that. Now let me execute this command. This nginx image is not found locally, so it is being pulled. As I said, this run command also will pull the image if it is not there. See what happened? A volume with some anonymous hashtag is created. Okay, created. Now we are into container. By default, I'm sure that this data 01 directory won't be there in default nginx, but what we are doing, this command will create this directory if it is not existing, and it will create a volume for this particular, it will mount a volume for this directory like this, and that volume name is this some random hash. Now let's go inside this. Now exit from this. How to interrupt this process? Control C. That's fine. CD var let docker volume. Now let's go to this volume. Now let's go to this volume. So here another directory will be there. Underscore data. Okay. In this actual data will be there. Now let's see. Now execute this command here in this directory. Okay, it will be executed, it will be refreshing. Now let's do one thing. Now let's go to this cd data 01. So we don't have any file. Let's create a file here. Touch file 1 and observe here what will happen. See, now touch file 2. See, these files are being synced there. Right, now let's remove file 2. File 2 got deleted here, so it got deleted here as well. Now let's create touch database file. See, that came here. Now let's do one thing. Now let's create files here. Now we have seen that we are creating the files in this directory and those files are being synced here. So even if this container is deleted, still those files will be there here. We will see that. Now what I'm trying to do is, let's create some files here and see whether those files will be saved here as well. Control C. Now touch volume file. Let's say volume file. Now let's come here and check whether that file came into this container. See, volume file. So both the ways it is working. The files which you create in this will also be synced here, and the files that you will be creating in this directory will also be synced here. So these two are in sync, right? Now what I'm trying to do is, we have created some files here. Those files are there. Now unexpectedly or expectedly, this container got terminated. Now let's remove that container. Docker rm the container id. Okay, now let's see whether the data is there or not. Still the data is there. Still that data is there. irrespective of the container life cycle, right? So this is the beauty of the volumes. This is what anonymous volumes. Let's say we may be having multiple containers. We will be having multiple containers. And for those containers, if we use the anonymous volume, then how do you recognize uh, the volume is related to which container? Whether you may be having database container, you may be having front end container, you may be having back end container, like that. You may be having some payment service containers, you may be having 10 containers. In that case, 10 volumes with different hashtags will be created. And if you want to see the files in the database, out of those 10 hashtag volumes, to which volume you go and see. You have to recognize, right? This volume is belongs to that a particular container. So how to name that? Instead of getting this anonymous hashtag, we will specify some name to the volume. That is called as what? Named volume. So as of now, we have only one watch and one ls. This is now let's see the concept of named volumes. Create a container with a named volume. How to create a container with a named volume? We just have to specify the name of the volume here. Earlier we have only this, and definitely we should provide the hyphen b. Now we are naming this particular volume. How we are naming? Like this we are naming. Like this we are naming. You can name whatsoever you want. Okay, here just for meaningful purpose, I'm using the container name and the directory on which this particular container is created. Sorry, the directory onto which we want to mount that volume, that name we have given, and we are naming that something like val. Now let's execute this command and observe the changes here. See, once again, the only difference from here to here is, here we did not mention the volume name. Here we are explicitly mentioning the volume name and use the colon and then the directory onto which you want to mount this volume. As simple as that. Now observe the changes, hit enter. Now see, a volume is created with what name? With this name. With this name. We are explicitly mentioning the name of the volume. Earlier we did not mention the name of the volume. So a volume with some random hashtag was created. Now we have improvised that. We got a volume with our own name. Now let's go to the data directory. Generally, which directory we will choose? For example, if it is MySQL data will be created in var-lib MySQL. So that directory we will mount. So here we are seeing some example. We will see that also. Now let's go to this. First exit from this. CD WAD. Now watch. Now go to data. Definitely have to go to data. Watch and one which command? ls command. Now write files here. Touch f1, touch f2, touch f3, right? So this is now rm f1 that got deleted. This is one. This is the named volume. Very simple. Now host volumes. Host volumes means till now what we are seeing, only volumes are created in this particular directory, Docker directory, where lib Docker volume, and we can mount this. Now, one thing I forgot to tell you. Now, let's remove this container. Let's delete this container altogether. Docker rm web uat02. If it is deleted, that that container is deleted. Now let's see, still the volume is there. Now tomorrow I want to create another container. Tomorrow I want to create another container. I want to use this volume in that container. This volume in the sense, if I want to use this volume in the sense, uh, volume in the sense, I want to get these files into the newly created container. How to do that? For that, for that, what we do is Docker run. Okay. Now see what we have done. This container was deleted earlier, so that's why we could not see that here. Now what I'm trying to do, I'm trying to create a container, a new container with this name, and I want to use those files. Now what I'm doing, I am using the same volume name and the directory. What is happening, and those files are also now coming into this container. Now to eliminate some confusion, now let me do one thing. Rm web uat02. Now there are no running or stopped container here, but still we have the data in this f2 and f3. Now let's create a Ubuntu container. And I want to get these files to that container. Docker run -name my Ubuntu. This is up to and the name is this. Image name is this. Have to specify that at the end. Next, what I want to do, I know that we have a volume. Okay, volume. Which volume? This volume. Copy this volume. Copy this volume. Copy this volume here. So that volume got copied. Now, what I want to do is, I want to mount this volume. I want to mount this volume to the newly created container, a directory of the newly created container, right? So now let's create, we can create another directory, mydir. If this mydir is not present by default in the Ubuntu container, this directory will be created, and whatever the volume that we have, the files in that volumes will be mounted in this directory. That means these files will be copied to here. Now let's execute this. So we have to give this, we have to interact with that first, right? Docker ps docker ps -e. Now let's start this container. Start. So there is no type of process running, right? So Docker start. I will tell that attach command later. This no such container. Yes, no such container. Container name is my Ubuntu. Now what I want to do is we have to interact with the operating system container as I said earlier. Now, what I want to do, I want to create a container called my Ubuntu, and we are doing that. We have to interact with it. So use -IT. So we are into this my Ubuntu container. Now this directory won't be there in the my Ubuntu. So this will be created and this one will be mounted to this directory. Now let's see. See, my dir was created. Cd my dir. These files got copied here. Now what we'll do? We will create some files here. Now let's say touch file 1, touch file 5. So those files will be there here. So we are creating few more files with this container, and those also will be created here. So each time we are using that volume and creating some files, all the files will be preserved here. We can mount that volume to the other container on some directory like we did here, right? So now Docker, let's do another small concept. So how to delete this volume? This we will see later. So Docker volume ns command is also there, where we will get the list of the volumes. So those volumes which are created in this volumes directory, those volumes will be listed here. Now that is fine. Docker volume ls docker inspect the volume name. So if you inspect when it was created, mount point, name, these things will be created. Scope is local, it is available local. You can't make it available outside of this. And one more thing here is inspect command is there for everything. You can inspect the container, you can inspect the image, you can inspect the volumes or the networks or other objects that we will see in the future. Now Docker image ls Docker inspect internet. See, we can also see the details of the particular image. Named volumes is there, host volumes. This is what we are trying to explain that, right? Host volumes means now we are able to successfully mount the volume which is there in the varlib Docker volumes. So that volume we are successfully able to mount. What's the need for mounting? To preserve the data even after the deletion of the content. That is one purpose. And another purpose is if you want to mount the already existing data to some new container, then we will also use this. Then how to mount some directory of the host to the container? What does it mean? Let's say I have a directory here, host dir. Let's say my files. These are some of the files are there. Let's say in my files, touch file one, touch file three, touch file four. This is there in this directory. These are the objects are the files in this particular directory. Now I want to move these files where this directory is there. It is not there in this tab where lib docker wants. It is there on some path of the host. Now we want to mount this directory to the container. For that we have called another volumes called host volumes or the bind volumes. In this case, what we do here is now let's create a container and name that as the web UAT, right? Then let's mount this to this, and before that we have to change the permissions of this. Now for this directory, for others only executable permissions are there. Now let's give permissions. Let's give all the permission to this directory as of now. The directory name should be my files. That will be meaningful. Now what I want to do here is now let's create a directory call. Let's create a container docker run type a name my Ubuntu interact with it. Now volumes. I want to mount a volume. What's the volume name? My file. Then let's do that. Let's give some my volume. Let's give some useful name. CD my volume. Touch file one. Touch file two. These two are there. And now give all the permissions to this directory. Now docker run hyphen name. Name is my Ubuntu. Interact with it. Now what I do, I will mount this volume to this container. Volume, which volume? Host volume. Host volume. What's the volume name? My volume. And which directory of the container? Now let's create a directory called my directory, or yeah, let's name it as my files. My files here. This is my volume. Let's create a my files directory here. And what's the image name? Ubuntu. Now hit enter. We are into the docker container, and the files that are there in this my volume should be coming and copied in this my files. Check that this my files directory won't be there by default. So if we specify this, it will be created. CD my files. Now if you see something happened. Something what happened to this?
You have not created my volumes, right? You just created my files on the local host.
No, my volume I have created. This is my volume. Am I right? My volume has been created, right?
Created, you can try giving a complete path of my files. You just
This my files is
My files is only for the container. It's not necessary. It has to come directly there. That's what he's checking.
yeah,
My
that's
inside, if the folder is created, only the files are not there. The directory is created.
yes, yes. It is created. Files are not there.
that's what I'm saying. From root directory, you just give just have given my hyphen volumes, right? You just give the path starting from root of my volume.
Okay.
Okay, okay.
Yeah, got it. Got it.
Then it will be properly mounted.
Docker rm my to. Okay. Now, okay. See my volume. Okay, let's do that. Clear the screen.
Only slash is enough. Slash my value.
Yes, yes, this class is enough. It is root.
Root.
Error is to create a root.
Root is
Okay,
not
oops.
necessary.
Yeah,
Root is not
got
necessary.
it, got it. CD my files. No, still we are not getting.
Can you do PWD of where you have created the my volumes?
Yes, I have done that. We have created that in the root.
Root only. Okay.
Root only. Docker rm my to. Let's try that also failed, right? Now we got it, right? So it is there in the root, and root is root user. This is the root user directory, and this root user directory is there in the root, related to root, right? So this is, so what we have done, we have created a directory on the host machine, and we have created some file there, and those files, that directory called my volume, we have mounted to the container volume. So if that is the case, what happened, so those files got here also. Now if we create few more files here, and those files will be coming there as well. File 3. Now let's exit from this container altogether and remove the container completely. Now go to my volume. So here this file 3 got created. This is the volumes concept. In Kubernetes, we will understand this, we will understand the real-time use. We have the persistent volumes claims, storage classes, all those things we will see. These are the steps for those, that concept. You got it, that's fine. Most also we have seen. So these are the, now shareable volumes means,
One question, Lakshman. Like, can we mount my base machines any of the directory to the Docker? Like, no, now you are creating one directory in Linux machine, which you have.
yeah, you can do that. You can do the, what you are telling is, which one you want to mount.
No, 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 not here. Like your base Windows machine directory, not
Oh,
the.
this one,
Amazon.
okay, got it.
Yeah.
We have the NFS server, right? We have to create NFS server. Okay, NFS server, through NFS, through network, that should come, but I don't teach that here. We just have to understand the volumes concept here. In real time, what we do, we don't use this kind of concepts, right? But these are the steps. We have to understand these to understand the Kubernetes volumes and all the volumes concept. So in Docker, do we deploy the application directly using Docker like this? We don't do that in real time. In production, we don't do. For example, a developer is there. A developer wants to test a containerized application and wants to run it and see whether these files and all those things are being there or not. For that, it will, during development, it will be helpful. But in Kubernetes, we will see that this is our Kubernetes cluster, let's assume. Then what we do, we will create the volumes outside of this Kubernetes cluster. Let's say we will be having our own Windows machine or Linux machine. We will create an NFS server into that in Linux or the Windows. In our case, we will see in the Linux. We will create NFS server. We will run NFS server. We will give the details of the NFS server and all those things in the volumes, so that the files which are created in this particular Kubernetes cluster will be coming here. That is one point using NFS server. And the thing is that, for example, you have Elastic Block Store in AWS, and Elastic File Share is also there. Coming to Azure, we have Azure File Share is there, and Azure Blob Store is there. What we do, your cluster may be running in AWS, and your storage may be there in the Azure cloud. In that case, what we do, through network, we will mount this Kubernetes deployments directories into that thing. We will understand all those things in the Kubernetes. But as of now, we are mounting onto this thing only. If you want to go to how to do that, mount the container directory on NFS server. See, first we have to create the Docker volume like this, or else also let me go to I have formatted in the other. See, first what we have to do, you have to install an NFS server on some container, on some host, whether it can be Windows or what. So we are creating a volume. Here they are using option type NFS server IP address, and the NFS server directory. Okay, so a volume will be created and that will be mounted to our container. So these are the steps to create an NFS server.
Okay.
See what we are doing, we are mounting it here.
No,
right?
without this NFS server, I'm just asking, in your local machine, can't we mount your?
No, we can't do that. We can't do that. Local machine in the sense you are talking about Windows machine, right?
Yes, your Windows machine, your
But
base Windows.
my Docker is running in Linux machine, and I can't mount this. If I want to mount Windows machine volume here, directory here, definitely we have to create NFS server. Otherwise, how we will transfer the files from here? Definitely some NFS protocol must be there, right?
Okay.
Yeah, we can't do that. With network NFS only we can do that directly, because how we have connected from here to here, definitely not. But if you want to copy my Windows file to in this Linux machine using mobile extern, you can do that. For example, let's say, let's go to that. This is the directory. So sorry, not that. This is the directory. Now let's go to root of what is happening. So what I'm trying, if you want to copy the local files to your Linux machine, then you can use this SSH browser, which is related to this Linux machine. You can upload files to this Linux machine and you can mount. Otherwise, the only other way is you have to create some network file share. With that only you can do that thing. What it is? Browser.
Will you cover NFS mounting when you do Kubernetes class?
Yes, I will do definitely. That is
Okay.
very important.
Okay.
Okay, there you will understand, right? Now, NFS server will do, EBS also we will see. Both the ways. Both will be used in the real time. Now, that is the host path. Other thing I wanted to tell is shareable volume. Shareable volume means, like for example, we have mounted a volume. We have mounted a volume to this particular data directory of the CentOS container called C1. And what we are trying to do is we are creating another container and C2. And whatever the volumes that are there for the C1, we want to mount that volumes onto C2 as well with command ---- volumes from. I want to get the volumes from C1 so that those will be coming here. Now let's do that. An anonymous volume will be created because we are not explicitly naming that volume. Right? So data directory is there now. Let's create some file here. File 1, touch, file 2, file 3, file 4. So these are all files created here. Now control PQ. Control PQ. If we use exit, then it will be exited. Container will be exited. If we use control PQ, container won't be exited. Only we will come out of the terminal. See, our container will be still running. Now let's create another container called C2 and let's interact with it. Now let's get the volumes from the C1 container just now that we have created. See this data directory is also there here. That files are also copied here as well. Those files copied here. This is the beauty of the volumes. Now let's remove all the containers. Stop and remove all the containers with this command. This is now. So you can get the volumes, C2 volumes into C3 like that can do. Or else you can directly mount that volume. Now, how to connect to a container which is running in the background? For that, we use the docker attach command. Docker what we have done earlier, let's use that command only. Now, let's create a container with this. If we use control PQ, it is going away, right? Now, how to attach a terminal to that? Docker attach C1. This is one thing. Otherwise, also you can use exec command. Docker exec it C1 into the terminal. This is one of the command. Then docker rm f then that's fine. Docker networking. This is one of the important concept. Docker networking. That means we have we have created containers inside the Docker host, right? Then we should establish connection between two containers. We have seen that using -link command, we have achieved that. And there is more advanced way. The -link command got deprecated, but still it is in use. But some advanced version came for that. That is networking concept. Two containers, if they are attached to the same network, they will be able to ping each other with their host names. We will see that. So there are different kinds of networking in Docker, and Docker uses network drivers. We have bridge network, we have host network, we have none network, we have overlay network, we have Macmillan network. That means if you see, let me read this theory. One of the reasons Docker containers and services are so powerful is that you can connect them together. Now let's say that we have a front-end container, we have a database container. How to establish a connection between these two? For that, we have to create a network. We have to create a network object. To that network, we have to attach these two containers so that now these two containers will belong to the same network and they will be able to ping each other. Very simple concept. And there are different types. For example, bridge network means this bridge network will be a local network and it will connect to two containers. And this network is independent of the Docker host network. That means our Docker host is running in which network? In a particular VPC. If we have the knowledge of the AWS, our Docker host is Docker host belongs to this network. This is the subnet and VPC. This is the VPC ID. We will see the CIDR block. Definitely it will be something like 172.31. So our Docker host is belonging to this network. That is the network of the Docker host. Now for Docker containers, different networks will be there, and this network will be created using the some drivers. So Docker supports networking for its containers via network drivers. We will discuss how different network drivers will be used and what is their role. For example, if you want to access the container directly with the IP with the network of the host, then without port mapping you can do with the host network. And if you want to completely isolate a container from the other containers and the Docker host, you can attach that container to the none network. That means there is no network for that container. And for internal communication of the container, we will be having the bridge network. If you want to access that container from the outside world, you have to perform port mapping, because the Docker network is different, Docker host network is different, Docker containers network is different. If you want to merge them together, we have to perform the port mapping. This concept we will understand tomorrow. This is one of the simple concept. Then after that, we will move to the Docker file, which is the heart of the Docker course for developers and DevOps engineers. This is very, very important section of the whole Docker course. That's it for today, friends. So if you have any doubts in this volume concept, you can ask me.
What kind of scenario will use the shareable volumes?
Shareable volumes, as I said, in real time it will be using, but in production, for example, let's say, uh, let's say we'll be using in development for sure. Let's say we have an application. Okay, we have an application. It has generated some data. We have application running inside the container. It has generated some data. Let's say app1. And this application does not have the capability to process it. And for that, the job of another container will come into picture. Okay, some files got created here. Some files got created here. Let's say file 1, file 2. Okay, and these files should be processed further by the another container, right? So these files should be coming here, and these two containers are running. Instead of mounting the data, that volume, if it is anonymous volume, we won't be having any particular name. A random hashtag will be allocated for that. But I don't want to go to that volume and check what is the volume. I don't want to mount it here. And one more thing is that continuously this application 1 may be generating some data simultaneously that should be processed by the application 2. In that case, seamlessly the file should move from here to here. Okay, so in that case, what we'll do, we will copy, we will sync the volume of this and we will mount that to this application too, so that the seamlessly files will be syncing from here to here, and that processing task will be done by this application which is running inside the container. And after that, if some other container has to do some other work for this processed file, then we will create another container and that application will be running here, and we will get the volumes from here to here now. This is how it will happen, right? So that is how it is useful. But believe Kubernetes, what Kubernetes does, Kubernetes will orchestrate the containers, and all these concepts we will be having in the Kubernetes also in some higher level. But to understand them, we should understand these things, this mounting, this networking, these are also will be covered in the Kubernetes, but they are different kinds of story, different kind of story will be there in the Kubernetes, right? So we will be using NFS, Azure storages, Elastic Block Store, which will be independent of the Kubernetes cluster, and still we will be able to mount the volumes there, and that volumes can be shared with the other deployments that we will see. Real case, for example, let's say you have SMTP server, not SMTP server, we have the RTSP protocol. So some live videos will be streamed. Those live streamed files will be created in this container, right? Those will be saved here, and we have to push them to other application. We will be using some messaging queues like RabbitMQ. So for that, what we have to do, we have to mount this volume to the RabbitMQ, and it has to process, and whatever the application that will subscribe to that RabbitMQ, and that will be getting the particular files in that particular application. They may be non-containerized applications as well. Okay, we will see those things, volumes concept in Kubernetes. Okay, that's it for today, friends. Okay, thank you very much.
One question, when you share this volume from one container to another container, what kind of level of permission it will have? Full permission or only read?
The permissions will also be whatever the permissions that we have for that volume, those permissions will be copied. Okay, you try and you see, you practice. If you have any doubts, you can ask me. Okay.
Sir, in these all the videos are shared.
All the videos are shared by the admin people.
Only that this document is not shared. This file document.
This is shared. Today I have shared it. Okay.
Maybe yesterday the folder was there, material. There was no file inside.
Yes, yes. So that is not there. Today I have shared till the networking.
Okay, okay, thanks.
Okay, after that.
Sir,
Okay.
can you please add me in,
friends.
right?